Call someone a reptile, and they aren't likely to take it as a compliment. But reptiles, including turtles, lizards, crocodiles, and snakes, have been around longer than we have. Scaly skin and cold-bloodedness must have their advantages. Here's one. A reptile's scaly skin helps it keep from drying out. Amphibians, like frogs and toads, are far more limited in their travels. Their moist skin makes them completely dependent on water, and they rarely live too far from it. Scales have other advantages. Snakes use them to help grip the ground. In most snakes, belly scales form overlapping plates. The plate's loose edges catch the ground and help produce a snake's legless glide. In turtles and tortoises, some scales have evolved into armored shells. Land-based tortoises, like the enormous Galapagos variety, have high domed shells too big to bite. Sea turtles' body design makes moving awkward on land. Their shells are streamlined for underwater mobility. Under that scaly skin, reptiles are vertebrates with a host of unique adaptations. Crocodilian design works well in water. The long tail makes swimming easy. And a flap in the back of the throat keeps water from rushing into the lungs, allowing crocodiles to breathe underwater. A few smaller land-based reptiles, like the horned lizards, are well adapted to desert life. With few places to hide, horned lizards' camouflage helps them fade into the background, and an impressive array of spikes discourages predators when the camouflage isn't enough. As varied and complex as the habitats they occupy, reptile species outnumber mammals. And though we refer to them as cold-blooded, their blood may be as warm or warmer than ours. The term means only that reptiles can't regulate their own temperatures and use behavioral means to heat up or cool off. Ancient mariners traveling to the Indonesian island of Komodo scrawled the words, "Here be dragons," on their maps. They were right. The largest predatory lizards in the world, Komodo dragons, make their home in the savanna regions of southern Indonesian islands. Forked tongues lead these lizards to their prey. Like snakes, they taste the wind. When conditions are right, Komodo dragons can smell a meal 5 miles away. Real dragons don't breathe fire, but they do have deadly bites. Loaded with bacteria, dragon saliva spreads disease, and animals, like this water buffalo, die slowly and painfully from infection. Patient hunters, dragons are monstrous eaters. They tear at flesh with large offset teeth as effective as serrated blades. The bigger dragons get the most, and full-grown dragons eat up to 80% of their body weight in a single meal. Young dragons live in fear of adults. They spend their first 2 years in trees, and later approach group feeds with great caution. speed alone protects them from their own kind. The only thing threatening to full-grown Komodo dragons is heat. Cold-blooded, they need shade and rest during the hottest part of the day in order to regulate their body temperature. But things naturally heat up during mating season. Big males charge each other and inflate their bodies, desperate to appear more ferocious and larger than their rivals. Once a dragon pins his opponent, the loser must endure a humiliating claw raking as well as the loss of mating privileges. Although females have nothing to do with their young, they fiercely protect their eggs. Digging a 12-foot-long lair, dragons deposit 30 to 40 eggs and go for 3 months without food while they stand guard. Even larger, male intruders are driven off. When the young hatch, they enter the world cautious and alone. Instinctively, they run for the safety of trees where camouflaged skin helps them hide. If they survive, these timid youngsters will turn into real dragons in just 6 years. Breaking through the sea floor, volcanoes erupted some 3 to 5 million years ago and created the Galapagos Islands, 600 miles from any other land. Animals living in such splendid isolation changed over time, adapting to the circumstances found here and nowhere else. Such change is called evolution, and marine iguanas, the only diving lizards in the world, are prime examples of evolution in action. Scientists believe that marine iguanas were once land-based like all other lizards. Perhaps violent storms swept them to sea and far away from their native South America. Fortunately, iguanas have a tolerance for salt water and are able to go without food for long stretches. These traits kept them alive for the long voyage to the islands. Barren volcanic rock offers up next to nothing for marine iguanas to eat. These animals looked back to the sea for food. No doubt they started at the water's edge, eating crustaceans, algae, and the occasional grasshopper. Most iguanas still feed here, taking advantage of exposed reefs close to shore. But the more adventurous, typically male marine iguanas, go diving for dinner. This unique adaptation allows them to take advantage of algae salad as far as 40 feet below the surface. A typical dive lasts 5 to 10 minutes, but iguanas can stay under for an hour. All that diving chills iguanas. They lose as much as 10 degrees in the water, so sunbaths are an essential part of the daily routine. Then there are the salt showers. Because of their salty diet, marine iguanas have developed salt glands above their eyes, connected to their nostrils. They just sneeze the salt away. How successful are these customized critters? Their numbers are some 300,000 strong. Streamlined to perfection, the world's 2,700 snake species undulate, sidewind, and even fly through life without limbs. All snakes hear nothing more than vibrations. They're missing an external ear, and their middle ear is poorly developed. When captive cobras dance, they are deaf to the music. Their actions are guarded responses to movements in front of them. Eyesight, important to most predators, may or may not matter to snakes. Pit vipers, like rattlesnakes, have poor vision, but hunt with deadly accuracy. The pits just below their eyes act as infrared sensors. A mouse is hot to a rattler, even in the desert. The snake can detect differences between prey and environment of 1/2000th of a degree. Who needs eyesight when you can read the wind? Snakes can also taste the air. The constant flicking of forked tongue is far more than a nervous habit. While the tongue seems to be idly waving in the air or touching the ground, it's picking up scent molecules and taking them in. Once inside, the chemicals are recorded by a snake's Jacobson's organ on the roof of its mouth and interpreted by the brain, identifying predator and prey. The wagging tongue proves to be an elaborate tracking device. Since all snakes are animal eaters, their senses have been highly refined for hunting. And they hunt successfully in every conceivable environment except one. Snakes have enough sense to stay out of extreme cold. You won't find them living north or south of 69 degrees latitude. Like all reptiles, snakes need an external heat source to keep them warm. Walk like a lizard, and you'll find yourself moving more like a fish than a mammal. The side-to-side motion works well in water, but presents some limitations on land. Study the swagger, and you'll notice that lizard legs are mounted sideways and bent. The muscles that sway their bodies from side to side are the same ones lizards use to breathe. Rapid movement constricts their lungs, so lizards have a hard time breathing on the run. It's no surprise that they're better sprinters than distance runners. Mammals have a much more efficient system. Their movements actually help them breathe. With spines that move up and down instead of sideways, and legs tucked neatly underneath, mammals like these lions inhale when the spine stretches out, and exhale when the spine contracts. In this body design, the same muscles are still used for running and breathing, but the structural differences allow mammals to run farther, faster than lizards. One group of lizards has a slight advantage over their relatives. Monitor lizards are outfitted with a breathing pump in their throats. This X-ray footage of a monitor on a treadmill shows the pump in action. As the lizard runs, the throat pump pushes air into its lungs. Lizard locomotion may have its disadvantages, but lizards have been around far longer than modern man. Their body plans were established some 200 million years ago and even survived the great dinosaur extinction.